Good morning, ladies and gentlemen. Hope we're doing well on this fine Wednesday. Can you believe how gorgeous yesterday was? Man, 66, sunny. Hope you guys were able to get out. So, I'm in my student account. All right. And use the slides. Oh, crap. That is wrong. It should not say Tuesday, April 7th. That should say Tuesday or Wednesday, April 8th. I made it correct here. But here are the slides over here. I have a few check-in questions, but today our topic is learning about seismometers, seismographs, and seismic waves. Make sure you say here, so then we can mark attendance correctly. Office hours are from 12:30 to 1, just like yesterday. Make sure you say here before 11:59 p.m. So that I can make sure attendance is taken correctly. So, test student, Wednesday, April 8th. Here's my copy. All right. Something that it says, wait until my video is shared before starting. Notice how there's no resource down here. That's because I'm making the video right now. So that's why you haven't seen it yet, because it's 7:02, 7:06. So need a few more minutes. All right, so starting Wednesday, April 8th, seismographs and seismometers. So on this first page here, just want to show you what these tools are. Okay, seismometers is this entire instrument. Okay, this one's kind of small, they can be bigger, but the tools are all the same. They're tools that measure seismic waves traveling through the earth. Okay, our earth is constantly changing, constantly shifting, and there are always waves that that these seismographs can pick up. The bigger they are, though, the stronger the earthquake or the stronger the feel is. Seismographs are the actual graphs that get made from the seismometer. So you can think of seismometers and seismographs as kind of like a computer. Okay, the seismometer is the computer's the tool, but the seismograph is like this Google slide. It's what the computer can actually make, recording seismic waves. Okay, this slide, bit more informational, but these red dots or pink dots at the time of this article being posted shows where most of the seismometers are located in the United States, even one in Canada. Okay, or I should say the continental United States. There are some in Alaska, some in Hawaii, but these are the locations of ones in the continental United States. Okay, so they're located all over the world, and there's a reason why, and we'll explain that a little bit later. So what do seismographs, seismometers kind of look like? What you have to do is continue watching this video for the tutorial, or you can try it yourself if you log into explorelearning.com and use the passwords that I will share after this video gets posted, for those of us who may not remember the passwords. There are a couple gizmos that you can try out and see for yourself. I also shared, kind of anecdotally, if you want to see Earth seismic activity live, go to this link and you can kind of watch seismic activity around the globe. So, as we keep watching, seismometers, seismographs, and seismic waves. Okay, while using the video, we're going to try and answer these couple questions. Okay, which waves will reach the recording station first, and which waves are represented with a stronger signal strength on the seismograph? Well, to do this, again, I'm going to log in to our account at EL Gizmos. Okay, the first one we're going to look at is the recording station. Okay, this kind of shows you how seismic waves might travel through the earth and what it might look like at a different station. Okay, so the first thing before we start showing anything is these two symbols: location of the station, A. Okay, this is where the seismograph is. Okay, this is where our seismometer and seismograph are located. Okay, the tool that measures and records seismic waves. And then this target here, this deadeye symbol for any gamers, you know, this is where the location of the earthquake is. You can think of this as the location of the epicenter and focus. This is where the earthquake is going to start. Okay, so I'm just going to move them about 700 kilometers apart. That'll help us to start. Okay, so our first kind of couple check-in questions we had is which waves are going to reach the recording station first? Well, let's hit play on our simulation. All right, I'll go full screen for now. So again, here's our earthquake, here's our seismometer, seismograph recording station, picking up the signals. So I'm going to hit play. All right, everyone watch, everyone see. So first, as we through that demo, we have to, again, ask ourselves, which waves will reach the recording station first? Well, in our gizmo, we have P waves and S waves. P waves are recorded in purple. S waves are recorded with this bluish green color. Let's hit restart. So which waves are going to reach there first? You see the purple, you see the pink. Which one hit the recording station first? You can answer that in your slides here. Okay, just answer it on the next line. I liked how some of you guys were doing it. As I was looking through some of your answers yesterday, some of you did actually delete the answer that was wrong, but some of you also, wrote your answer, so we can say, well, which one is it? P waves or S waves? Probably most of you would say P waves. So you answered it, but then what you did to kind of help me notice it better is you made it bolder and you added, oh, that's not what I wanted to do. You changed the text color or the highlight color, so then it was whoa, do not do yellow. That is impossible to see. You changed the highlight color so then I could see your answer very clearly. Okay, so if you can continue to do that, that would be fantastic. That'll help me, that'll help Miss Jones, that'll help Miss Olson, that'll help anyone who wants to come in and check our work. So great, the P waves reach the station first. All right, and notice these lines here. Those lines, the bouncing up and down, shows the signal strength. That's kind of like how hard or how strong or how much energy that earthquake wave, seismic waves carries, how much energy it has, destructive force. And then look, the S wave hasn't hit yet, so we haven't seen the S wave hit. But let's keep playing and we're going to see a big change. Boom. The S wave hit. So we know that the P wave hit first and the S wave hit second. So I'm going to mark the start of the P wave kind of with this green symbol, and then the start of the S wave with this blue symbol. So just anecdotally, about 80-second difference between P waves and S waves. So that's like a minute and a half, about 2 seconds less than a minute and a half. So which waves hit the recording station first? P waves. Now, which waves are represented with a stronger signal strength on the seismographs? Well, which one had the larger bouncing in the y direction of this graph? Well, P waves went this far, S waves went that far. So that'll be your job to answer which waves are represented with a stronger signal strength. Okay. Now, using the video still, we're going to make a couple more observations. How will the seismograph look if the recording station is further away from the epicenter of an earthquake? Okay, so we're going to reset and we started here, but let's put the earthquake and the seismometer as far away as possible from each other. Okay, let's watch and see what happens to this graph. Okay, so I hit play. Let's watch and see what happens. So, if we're far away from an earthquake, how will the seismograph look if the recording station is far away from the epicenter of the earthquake? Well, how does it look? Remember what a seismograph and a seismometer do. It's their job to record seismic waves and seismic activity of the earth. Is there much seismic activity going on? That's for you to answer here. How will the seismograph look? Is there much seismic activity? What's going on? Okay. Last one, number 2. How will the seismograph look if the recording station is closer to the epicenter of the earthquake? Well, let's compare. So let's move the epicenter and the epicenter of the earthquake and the recording station much closer together. Now they're only 90 kilometers apart. That's about 52 miles about. So let's see what happens here. 52 miles away. Let's see what happens at our recording station. Wow. Wowee, wow. So, notice what happened right off the bat. What did our recording station feel? Okay, did it feel a stronger signal? Did it feel a weaker signal? How can you tell? All right. And so you can even take it a step further and kind of, well, let's not get ahead of ourselves. How will the seismograph look if the recording station is closer to the epicenter of the earthquake? Well, you tell me. Is there a stronger signal strength? Is there a weaker signal strength? Is this earthquake going to be more destructive? You tell me. All right. But think of it like this. So say if St. Paul was right here and our earthquake was this far away, let's just say. Okay. And we have the earthquake hit. Is this earthquake that is 820 kilometers away, so about 500 miles away, okay, is that earthquake going to be as destructive as an earthquake that's only 90 kilometers away? So that can show you a relationship that the closer you are to an earthquake, the more destructive force that you'll feel, the more danger that you're in, the stronger the earthquake is going to feel, because as that energy disperses, spreads out, the energy it carries gets a little weaker. Part of that is due to friction in the crust. Part of it is just overall resistance that causes the earthquake to get a little weaker. Okay, I'm noticing I don't have a ton of time left. So how can we locate an earthquake? We use this process called triangulation. And what triangulation is you have 3 different seismographs, boom, 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 in 3 different places. Okay, that's where the cities are, those orange dots. Okay, and they can all pick up seismic activity. All right, so if an earthquake happens, eventually it spreads out and all of them pick it up. But what they do is they find the intersection point of a circle that fits all of them, kind of depending on their strength. Okay, and in the next video I'll post, I will share. But that'll conclude the first video I have for you. You're able to answer questions on slides 5 and 6. We'll come back and make another video for slide 7, 8, and 9.